Hello, everyone, and welcome to Software Architecture Monday. My name is Mark Richards, and I'm going to interrupt our journey through these architecture styles because we are at a point where we're going to switch between monolithic and now start to look at distributed architectures. But I wanted to interject a lesson here, number 161, talking about some confusion that a lot of you pointed out with regards to some of the things I showed when to use monolithic architectures and when not to. And that has to do with overall agility, but then time to market. So you can get a listing of all of the lessons I do on Software Architecture Monday at my website, developer2architect.com/lessons. As a matter of fact, the last three lessons that we looked at were lesson 158, where I talked about the layered architecture, 159, where I talked about the modular monolith, and lesson 160, where I talked about the microkernel architecture. All three of these lessons and all three of these architectures had something in common. These were all monolithic architecture styles. And if you've been following, you'll notice that there was a commonality between all of these. In each of these architecture styles, I talk about when to use these and when also not to use them. What was common between all three of these monolithic architectures is when to use is when you have fairly significant time constraints or budget constraints. But then I think I created some confusion because I said when not to use is when you have high time to market needs, which is in the form of architectural agility, the ability to respond quickly to change. And I did receive quite a few comments and questions about how can you say that it's good to use for time and budget, yet you're saying it's poor time to market. And I wanted to explain that difference. I want to talk first about when to use those time and budget constraints, because there is a reason why these two exist in the when to use, when not to use area. When I was talking about when to use these monolithic architecture styles, all three of them have the superpower of being fairly simple and fairly inexpensive. And those are the times to use these, especially starting out or migrating to these architectures. And let me explain what I mean. So all three that we've looked at so far are all monolithic architectures. We're about to embark on our journey into 5 different distributed architectures in the next 5 lessons. But over on the distributed side, over here, it's fairly complex. And that is what impacts significant time constraints and budget constraints. As a matter of fact, the very first thing we start to encounter are those fallacies of distributed computing. Those things I talked about, I believe it was lesson 12. So if you go in the catalog, it was a long time ago. But I talked about the 8 fallacies of distributed computing, because in distributed architectures, we are using the network. But it goes beyond those 8 fallacies of distributed computing, because we have a lot of inherent complexity in what we're about to see in the next 5 architecture styles we're going to take the journey of. So, matter of fact, that complexity is wrapped around decisions about distributed architectures and eventual consistency. It's about service granularity and the struggles we have about getting the size of a service correct. The workflow coordination, whether we should coordinate these services through orchestration or whether we should use choreography and the corresponding trade-offs. All the shared code and utilities that we nicely package within our monolith that everybody has access to, we don't in a distributed architecture. Should that shared functionality be a shared library? Or should we make it into a shared service? And there's significant trade-offs about each of these as well. What type of communication protocol should we use between these services? Should it be simple REST calls? Should it be a messaging, maybe events, gRPC? We've got a lot of choices to make. Also, whenever we communicate in a distributed architecture, we need a contract. What does that contract look like? How do we version it? How do we maintain it? Should that contract be strict, like a JSON schema or XML schema, or should it be loose, like simple JSON name value pairs? And finally, the whole aspect of distributed data plagues us. And you can see as I'm describing all of these complexities, those don't fit well with a budget that's constrained or even a time constraint to be able to get this system up and running. But over on the monolithic side, it happens to be laughing. All three of the architectures we've seen are laughing at the distributed architectures because they don't have any of this complexity. So that's why when we have tight budget and time constraints, monolithic applications are much more suited for that kind of scenario than the complexity I'm drawing over here with the distributed architectures. Now, let's talk about the confusion, because I think most everybody, maybe most of you, kind of saw that piece and said, yeah, that makes sense because it's less complex, but then you're saying not to use it if you have tight time to market needs. I wasn't really referring to the initial construction or implementation of these kind of architectures, but rather the ongoing maintenance in terms of agility. And that is the ability to respond quickly to change. And this relates to speed to market or time to market for changes, bug fixes, new features that we add to the system. Now, it turns out agility translates into three things. It is a composite characteristic, which I talked about in a prior lesson. But agility is made up of three things: maintainability, testability, and deployability. Maintainability is basically the ability to be able to locate where in the system I should apply this change, or identify and fix a bug, or maybe it's a new feature we're adding. Testability is about the ease of and completeness of testing. And finally, deployability, which is about the ceremony of deployment, the frequency of deployment, and the overall risk. Let's start with our monolithic type of application or architecture styles, because the problem with monolithic applications is that everybody is making a change to the same code base, the same system. In other words, everybody's got their hands in the till, so to speak. And this makes maintainability rather difficult. I think that's the place that I make the change, but I'm not sure. There might be another place that's impacted. And what tends to happen is fires start everywhere. Because you see, this is the scope of the entire system. As a matter of fact, that's our testing scope as well, and our deployment scope. And the problem is, testability is about the ease of, but completeness of testing. And a lot of times what happens in monolithic systems, because everybody's making their own change, is sometimes these changes aren't coordinated. And fires break out in areas of the monolithic system that we didn't even touch because of the difficulty in fully and completely testing that monolithic application. But all these changes are all going in together. And this is why we have these long regression testing cycles and code freezes, which does impact deployability from that overall frequency of deployment. And our deployment risk is a lot higher here. So this suddenly becomes a shocking place to try to make changes fast in. Whereas if now we move to the distributed architecture side, teams or individual developers are making changes to a single service. And as a matter of fact, that change is isolated generally to the service, if we do domain-driven design properly, which means that maintainability is fairly good because I know exactly which service to go to apply that change. As a matter of fact, in each of these cases, my testing scope is a lot less. I can achieve a much higher level of testability, especially in terms of that completeness of testing. And my deployment risk is a lot lower. My frequency of deployment is a lot faster. And as a matter of fact, this becomes a fairly happy place to be able to apply quick changes and get those out to our end users or our customers as soon as possible. And so you can see these are two different concerns. It's about having tight time and budget constraints for an initial system, such as maybe a startup or not much money or budget available, or a time crunch where we, due to regulatory requirements or somebody's vacation schedule, have to get our changes out as fast as possible, that system out as fast as possible. And so you can kind of see now why that confusion about time to market being when not to use, because it's about agility, the ability to respond quickly to change versus the simplicity of a monolithic application if we don't have a lot of time or a lot of budget to get that initial system in place. So hopefully this is less, like I said, a kind of a midpoint between all of these architectures we're looking at, and just really wanted to interject this to answer those questions and that confusion that kind of arose about this difference of agility versus simplicity. So anyways, this has been lesson 161, Agility and Monolithic Architectures. In the next 5 lessons, we're actually going to be now looking at our journey of distributed architectures, and we're going to see a much different picture than what we've seen in the prior 3 lessons. So stay tuned in 2 weeks where we're going to start by talking about microservices, and we'll see you all then.